Hi, welcome to MLRIT. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity, MLR Institute of Technology, Hyderabad. In this video lecture series, I am going to teach data mining as per our syllabus. So, before we move on to the discussion, let us see what we are going to discuss in this lecture. And whatever the data we discuss, like suppose 181 by 2025, 181 zettabytes of data by 2025, or whatever the data currently we have in digital universe, the more than 80% of data is unstructured data. What do you mean by unstructured data? We can simply say we cannot apply directly any kind of analysis, or we could not apply any algorithms directly. So, the lot of pre-processing need to be done to convert the data which is in a raw format or unstructured format into the structured format. So, earlier we used to have this data called as structured data, that is completely organized, like let us take an example, a table in a SQL. Right, a student table, course table, a faculty table, or a department table. That information would be organized in the form of rows and columns. So, that is easy to process, but the data which is in unstructured format, because like suppose if you take a video data, if you take audio data, if you take a text data, like suppose if you want to do like a Twitter sentiment analysis, whatever the tweets you extract from the Twitter, that tweets may have unwanted stuff that need to be removed, or in the pre-processing, that all unwanted stuff should be removed. Then we could apply any other further analysis. So, that is another challenge, because of the available data is 80% of an available data is unstructured format. So, we understand the importance, why we need to perform the data, because we have the large abundant volumes of data, but we could not process as effective as possible. So, that is why we could heard a term called as data rich, information poor. So, that is the reason we need to apply this data mining techniques to extract the knowledge. So, I hope you will understand the definition easily because of what we had discussed so far. Based on that, it will be very easy to understand the definition of data mining. In simple terms, I could say data mining is a process. And another term we use, they use interchangeably because they do not understand the meaning, data warehouse. Data warehouse. So, data warehouse is a place to store the data. Data warehouse is a place to store the data, whereas data mining, it is a process. Data mining is a process, right? So, there is a large difference between these two. Few students, they did not understand because they do not have much idea about this. So, as per the Campbell textbook, the definition of data mining in simple terms, knowledge discovery from data. If we expand this definition, it is an extraction of interesting, like non-trivial, implicit, previously unknown, potentially useful patterns or a knowledge from huge amount of data. And there is another like a model, that is this model mainly used in industry, that is called as a CRISP-DM, cross industry standard, a process for data mining. It is an open standard process model that describes the common approaches used by data mining experts. It is most widely used analytics model. It has the components like understanding the data and data preparation, modeling, evaluation, the deployment, business understanding. All the concepts will be discussed in detail later. And coming to the architecture, this here, like how the data being converted from the raw data to the information to the knowledge, and what is the role of data mining, what are the different tasks could be done with the help of data mining. So from this you can see this, these are the different databases. So we collect the data in the different databases. So these data need to be integrated, because like let us take one simple example to understand why the data need to be integrated, and we will also do some kind of extraction, transformation and loading like ETL process, ETL in data warehouse. Like suppose if there is a company, or let us take any supermarket. So that supermarket has a few branches, right, in different cities across the country. Let us say it has 3 branches. This is branch 1, branch 2 and branch 3, etc. like this. So here the list of items and products or the prices would be different, and each branch, right. So the name of that product also would be different. Sometimes the product code might be same. So but the business analysts, they might be sitting at in one place, right, not. So in that case, so to take for any decision making or to improve the business, so they need to get the information from all the branches. Okay, so for that purpose, and this data need to be extracted, transformed and loaded into a single database. This mostly we use data warehouse. So that is the purpose. We are not going to discuss in detail because it is a concept in data warehouse we will study. So from the different databases, data is being integrated, and then as we just discussed, the pre-processing. So the pre-processing, the data cleaning need to be done, that is to remove the noise and the inconsistent data. And then the data integration, what we already discussed, right, there where the multiple data sources may be combined, and the data selection, right, all the data, all the fields or all the fields in a table or all whatever the data available in a database may not be important or interested. So in that case we have to select the particular data. So in this data selection, the data which is relevant to the analysis tasks are retrieved from the databases, and then the transformation need to be done in order to convert the data into the required format. In this transformation, the data are transformed and consolidated into the forms appropriate for mining by performing a summary or a aggregation operations. Then the data mining, by applying the different tasks in data mining like a classification, clustering, these are all divided into the predictive and descriptive tasks. So it is an essential process where intelligent methods are applied to extract the data patterns, like what are the products contributing more profit to the company, what are contributing the more loss to the company, the top selling products, etc. How the sales from the beginning of the year to the end, like quarter wise sales, like these kind of patterns could be analyzed or extracted by applying the data mining techniques. If you take one simple example how the data mining could be applied, in this we just quickly see what are the steps we could be applied, right, what are the different steps we can apply in this web mining framework. The first one is a data cleaning, that is need to be done in every data mining task, because we get the raw data, then the data integration from the multiple sources, the warehousing the data, that is mainly to store the historical data, and the data cube construction to perform the multi-dimensional analysis, data selection, right, whatever the data interested that need to be selected, and applying the respective data mining technologies, and presentation of the mining results to the end users, and then storing these patterns and knowledge into the knowledge databases. So these are the steps in a web mining framework. So then what kind of data can be mined? There are, as we discussed, the different types of data being generated from the different sources, like a relational database oriented data sets and applications like databases, data warehouse, transactional databases like daily transactions. And if you could see the advanced data sets and advanced applications like data streams, that is, the data is continuously flowing, we do not have a control on it. So we need the different kind of algorithms to process this data, because we are not going to store this data, and the data being that is generated from the sensor nodes, and the time series data which has the time, and the temporal data, the sequence data that is in biosequence, structured data graphs, social networks. There are some other different types like mainly the spatial data and the spatio-temporal data, multimedia databases, text, and then World Wide Web. So we could apply the data mining techniques for all kinds of data. So what are how the data mining is related to the other fields, like how we can see it is an interdisciplinary field. So it is a combination of like a pattern recognitions, statistics, so visualization for easy understanding and analysis, and mainly the high performance computing, that is because zettabytes, petabytes, terabytes of data cannot be processed with the normal computing machines. We need a high performance computing machines. And the database technologies like the structured databases like SQL, the no structured database, no SQL databases like that, and algorithms mainly, and then applications, and the machine learning also is going to play the major role. And what kind of applications are targeted? That is what like mainly the web analysis, like we could collect the clicks of users so that we could perform the click stream analysis. So collaborative analysis and recommendation systems to product recommendations, and the item recommendations or the user recommendations, etc. And market basket analysis, that is for the targeted marketing, biological and medical data analysis. These are the different kinds of applications which are targeted. And what are the major issues in data mining? Mainly the mining various and the new kinds of knowledge, because the most of the data which are available is more than 80% of the data is unstructured data, and mining knowledge in the multi-dimensional space, and handling noise, uncertainty, and the incompleteness of the data is another major issues facing to apply this data mining. So how we could handle this and noisy data, uncertain data, and incomplete data. So these are the major issues. And then in terms of efficiency and scalability, because the data is being generated continuously, the size of the data is increasing continuously, exponentially, right? So the efficient and scalability of data mining algorithms is another major issue. Parallel and distributed stream and incremental mining methods, like a parallel, like the terabytes and the petabytes of data we cannot store in a one disk, so that need to be distributed among the different machines, and the parallel processing also need to be done once the data distribution is done. Then the stream, like the data is continuously arriving, like we cannot control that. So that data we cannot store that data also because of the huge volumes. So that may arrive at any speed, and our algorithm should capture the data, the patterns from that stream data, and the incremental mining methods, etc. And the diversity of data types, like complex types of data like NoSQL data, there is no structure, and the dynamic, networked, and the global data repositories. So these are the major issues in data mining. So if you summarize what we had discussed now, we discussed the relationship between the data, information, and knowledge. Okay, without understanding the difference between the relationship between the data, information, and knowledge, it is very difficult to understand the rest of the concepts in data mining, because as per the data mining definition, it is a knowledge discovery from data. So we should understand what is difference between knowledge and information and data. Okay, so why data mining? Why data mining? I can write why data mining. So we have seen the definition of data mining definition, and some examples to understand the relationship between the data, information, and knowledge. And what are the different different experiments and different sources where the data, huge volumes of data being generated, sources of data, then different applications targeted, then issues in data mining. So thank you for watching this video. So next session we are going to discuss the different types of data mining.